Okay. So, first, before I tell you what our lesson is, first I want to see. First, I want to see what y'all know about these words. So, who can tell me what acceleration is, or what you think the definition is from past classes? Right now. Can you write on my whiteboard, please? Who can tell me what gravitational force is? Guys, it's okay. You just try gravity for all that matters. I just need you to try. You look like you got it. Who can do mass? That's what I like to see. Who can do net force? Newton's second law.
Oh.
Wait.
I can do that.
Which one will you do?
Newton's second.
Newton's law?
Well, I can't.
Y'all can just switch off videotaping my angles. It's okay, as long as you try your best. Sorry. Okay. I'll do another one for some more. There it is.
What was here?
Oh, you were Newton's second law. Here, go write it. I'll videotape you writing it. Great teamwork, class. It's okay, it doesn't have to be right. I just need you to give your best educated guess. Can you hold this, please? Celsius. Alright. Can anyone tell me, does anyone know the definition of net force or would like to try? Alright, so we'll just put a nice question mark. Oh, that's not a question mark. Okay, and the actual word is because then you'll know it all after I teach it. Alright, so this is our prompt. We're doing the why things fall side first. Who would like to read out loud our prompt to us? Thank you. Hit it.
Kathy had a heavy metal ball and Rich had a light wooden ball. They dropped the balls from the same height. They were surprised to discover that the two balls reached the ground at the same time. This is what they said after the balls landed. Kathy: the force of gravity must be acting the same on both balls. Rich: I don't agree. The metal ball weighs more, so the force of the gravity is more on the heavier ball. Whom do you agree with and why?
Please write down who you agree with, Kathy or Rich, and say why either one of them were right. Okay. Who did you put down?
Kathy.
Kathy. Who did you put down?
I put Rich.
Why?
Because since the metal ball weighs more, like it should hit the ground first. Because it's heavier. So
Alright.
force of gravity.
I like it. Who'd you put?
Kathy.
Kathy. Why?
Because they're being dropped from the same height, so they have the same gravitational pull.
Okay.
I think Kathy.
You put Kat. Rich is correct. But that is a common misconception that many people have, and we're about to watch. Well, actually, let's do our experiment first. So, here's all different kinds of balls. We have a bouncy ball. That didn't bounce. We have two metal balls. They're at the exact same weight, which we can get on the scale and weigh them. And we have these balls. So if we drop these, we have to see how they fall. So first, let's do the same balls. They're the exact same weight and same size and see what happens. So can you drop them from the same height? Just drop them like when you're doing it. Same height, hit at the same time. Do we agree? Okay. Now, bouncy ball and this ball. They're about the same, but tell me if those are the same weight or different weights.
Different weights.
Different weights. Which one's heavier? Alright, can you drop them from the same height? Okay. Do they hit at the same time? No. Drop again. Okay, that was pretty close. It might be because of air resistance. We'll talk about it.
There you go.
There we go. No, they hit the same. Which they're very different weights. Around the same size, hit. So now if we do two same size also from two different materials. This is plastic, this is metal. Can you drop these two balls for me? Yeah. So they hit the same no matter the weight or the material they are.
And shouldn't Kathy be right?
What did Kathy say? It must be acting the same on both balls? No, Kathy is not right. And you're about to watch this video and you're going to learn why Kathy was not right. It's a common misconception. And in this example, it talks about using a basketball and a medicine ball. Okay. Can everyone see this from here?
At exactly the same time, what do you expect to see?
Well, they're going to hit the ground at the same time. I expect them to both land at the same time.
At the same time.
I think they both, this one hit the ground first, however, they will actually both hit the ground at the same time.
Why is that?
Science. Yeah, science.
Well, the black one clearly feels a lot heavier. So the standard misconception is to believe that black ball will accelerate at a greater rate and reach the ground first. This year, many people had an idea that both balls would land at the same time, but they didn't know exactly why. I found there were some different misconceptions. For example, many people seem to think that as an object falls towards the Earth, it falls with a constant speed.
From this height, yeah, pretty much. Just constant speed all the way down to speed.
Yeah, I think it'll be the same constant speed.
I think it's constant. I seem to remember it being constant. I did decently in physics, and I seem to remember that's the answer.
Whereas the truth is, the speed of both balls is changing all the time. The balls are speeding up as they go towards the ground. That's what the force of gravity does on them. It makes them accelerate. It gets them to speed up. Another misconception I discovered was that some people believe both balls should have the same gravitational force on them, even though the black ball is clearly much, much heavier. The reason I think they said this was because they knew both balls needed to reach the ground at the same time, so they reasoned that the force on them must be the same.
Tell me about how the gravitational force on this ball compares to the gravitational force on that ball.
Force is the same.
It's going to be very similar in terms of gravitational pull. They're both the same and they'll fall at the same rate.
And they're like, it's the same gravitational force. Well,
The gravitational pull on the Earth is the same with both objects.
Are you saying that the force on them is the same?
The pull is the same.
But you felt the pull and you told me the pull is different.
No, I said the weight is different. I said the pull is different.
It is heavier. It has more gravitational pull. But when I drop them, then they get equal with gravitational force.
Don't you think it's going to be like 5 times as much?
Yeah, you think, but it's not.
The way you're asking it, yes, but scientifically speaking, no.
The gravitational force on both these balls are the same.
The gravitational force on both of these balls is the same.
Is that what you actually believe?
No, but it is.
Tell me what you believe.
I believe it should be more on this, simply for the fact that this is heavier. In intuition told me that it should be more, but after learning physics, we learned that it is actually the same.
I actually think the force on this ball is more than the force on this ball. I swear. I'm not trying to mess with you. So,
Like in real life?
in real life and in physics, I will tell you that the force on this ball is more. Alright, ready? 3, 2, 1.
Same time.
I would say the force on the medicine ball is like a lot more because it's got a lot more weight, it's got a lot more mass, but it's got a lot more inertia in it. Oh, you guys remember that, right? It's got a lot of resistance to acceleration, so it takes more force to get it accelerating at the same rate as this ball. And that's why they accelerate at the same rate. Thank you guys so much for playing along. I appreciate that.
So the key point about that video is talking about how we can have two different objects, same size, like the basketball and the medicine ball, but how the metal ball weighs more. So you're going to have, like if this weighs 2 times as much as this ball, you're going to have 2 times the amount of force pushing this ball down as it would take to push this one down. As would be, you have to have 2 times the amount of force to push the ball that would be for this one. So more mass, more force.